Hey, hello and welcome. In this video, we're going to look at how to solve for total resistance in this circuit here. This is a series parallel circuit. We see that. So when we look at this circuit, we can watch the current as it flows through, and we see that the first thing it does is hit a node, and we know current divides at the node. And so we should see that our IT then becomes two other values there. It goes partially down through R3 to get to point C here at this next node. And it can also go down the R1 and R2 branch to get to the bottom node here as well, right? So that means that we have two pathways, which gives us a parallel combination, but we also have an AND in the middle of those, giving us a series combination. And so we can reduce those out. We can say, let's add R1 and R2 together first, and then put in the fact that we know that those combination of resistors are in parallel with R3. And then we'd have the total resistance on the top all the way to point C. And then we'd work from point C down. Right? From point C, we could see that we have R4 going to ground. We also have another pathway from point C that leads through R5 and R6 to ground. So those two would be in parallel with each other. You'd have to figure out what the sum of R5 and 6 are, and then put that in parallel with R4. Right? So when we go for total resistance, we can just write that out. We can say RT is equal to, and we can follow out our current and say as soon as we hit a node, we'll open a parenthesis. We'll follow one pathway to the next node, and we see that that goes through R3 and hits point C. So we'll say R3 is in parallel with, then we go the other pathway up here, and we can say that we have R1 and R2. So we'll say that's in parallel with R1 plus R2. And see, I put that an extra set of parentheses there to make sure that I remembered to add those before putting them in parallel. We'll close that out because we're at point C here. This closes our node. Our two pathways joined back together, right? And at that point, we can continue on. We had no choice but to go through those two pathways at the top, though. So we're going to give that a plus sign, which means anytime you see a node that's kind of conjoined like this, you're going to think of it as the top is in series with the bottom, right? Because that's what's happening right there. So as we continue on, we'll see that we have a couple of more options here. We can go down through the R5, R6 branch, or we can go down the other pathway here through the R4 branch to ground. And so we can write those two out, and we can say that we have R4 in parallel with the other side there, which is our R5 and R6. Again, I like to put a little parenthesis around there to remind myself to put those in, as well as around this other R4 combo here, R4 in parallel with R5 and 6. That way, I can work innermost parentheses outward. I can combine these two here and then put that in parallel with R4. And then I'll have a total number here. I can do the same thing over here. I can put these two together, add them up, and then put that in parallel with R3. Then I have a total number here. And then I have a number plus a number. And that's going to give us what we want to do. So we're going to use that to calculate through our total resistance. So this is the relationship of our series parallel circuit. So now on our calculator, we can plug each one in because we know all of those values. So we have the first number there is a parallel combo. So we'll say 1 over 1 over, and we'll say R3 is 5,000. They're all in kiloohms. So actually we can leave them out of kiloohms. We could just say R3 is 5 and keep the thousands, and plus 1 over the combo of R1 and R2. So we can add them together right here on the bottom. We can say that we have 2.3 and 2.8. And as long as those two are on the bottom of that division together like that, then it will work out because it's going to series those together, sum them, and then it's going to put them into that parallel equation. So that gives us that first number there. Now we can say that we know that this reduces down to 2.525. Right, that's in kiloohms, so technically I can move that back out and it'd be 2,525. And so we can just write a k ohms at the end of that. We'll bring our plus sign down there because that's going to carry on. And then we can do the other side of our equation over here, which is basically the same thing. Right, so we'll say R4 is 2,000. We'll do 1 over because we're dealing with a parallel here. And we'll say 2,000. We'll put that as just a 2 plus 1 over the series combination of 5 and 6. 1.2 plus 1 for 1,000. And that's going to be our combination there. That's our second number. So we can say that we have 1.048 kiloohms. We can sum those two together. that out, and we'll say that we have 2.525 plus 1.048. That is our total resistance, RT. RT is equal to 3,573. We had to move that decimal place back, so if you wanted to keep it in kilo ohms, you could just keep it there and say 3.57 k ohms. Yeah. All right, let us know if you guys have any other questions.